This is geometry, section 6.2, properties of parallelograms. Our objectives in this section are to use relationships among sides and angles of parallelograms and to use relationships among diagonals of parallelograms. Please fill out your note template. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. This is parallelogram ABCD. The red arrows indicate parallel. AB is parallel to DC. BC is parallel to AD. In this section, it's essential that you understand parallelograms have special properties regarding their sides, angles, and diagonals. In a quadrilateral, opposite sides do not share a vertex, and opposite angles do not share a side. In this parallelogram ABCD, side AB and side CD are opposite sides. They do not share a vertex. Sides BC and AD are opposite sides. They do not share a vertex. Angle A and angle C are opposite angles. They do not share a side. And angle B and angle D are opposite angles. They do not share a side. They're opposite from each other. You can abbreviate parallelogram with the symbol, a small parallelogram, and parallelograms with this symbol with an S inside. Theorem 6.3. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So if it's a parallelogram, if you know the opposite sides are parallel, so if ABCD is a parallelogram because you know these opposite sides are parallel, then you know those opposite sides are also congruent. Angles of a polygon that share a side are called consecutive angles. They're angles that are one right after another, consecutive. So, angles A and B are consecutive angles. Angle A and angle B are consecutive angles. Angle B and angle C are consecutive angles. Angle B and angle C. Another pair of consecutive angles would be angle C and angle D. They're consecutive angles. And then we also have angle D and angle A. They're consecutive angles. So consecutive means one right after another, like consecutive numbers or 1, 2, 3, 4, 5, consecutive angles, angles that come right after each other. Consecutive. Theorem 6.4 is in relation to consecutive angles. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. The angles that come one right after another. We can prove this theorem easily because parallel lines cut by a transversal, we know that the same side interior angles, angle A and angle B, are supplementary. So you could prove this is true about all four pairs of consecutive angles. The ones that come right after each other have a sum of 180. If a quadrilateral, this is theorem 6.5, if a quadrilateral is a parallelogram, then its opposite angles are congruent. Opposite angles are the ones that are across from each other. So if you know it's a parallelogram, then you know the angles opposite each other are congruent. So in this example, angle A is congruent to angle C, and angle B is congruent to angle D. They're opposite angles. Theorem 6.6. If a quadrilateral is a parallelogram, so you have to know the opposite sides are parallel for all of these theorems, then the diagonals bisect each other. This is the one that people most often forget. The diagonals are the lines that connect the opposite angles. They bisect each other. So it doesn't mean they're congruent to each other. It means that they cut each other in half. So AE would be congruent to CE, and BE would be congruent to DE if E was that point in the middle. Let's check for your understanding. ABCD is a parallelogram. Find the following. We want to find segment AD, segment EC, the measure of angle ADC, and the measure of angle BCD. Pause the video and check for your understanding. For us to find segment AD, if this is a parallelogram, then I know opposite sides are congruent. So if BC is 8, then AD is also 8. If this is a parallelogram, for me to find EC, I know that diagonals bisect each other. So EC would be congruent to EA. So if EA is 5, then EC is 5. If this is a parallelogram, then I know that opposite angles are congruent. So the measure of angle ADC, so we're talking about this angle, I know it's congruent to the opposite angle, this angle, ABC. So I would find the sum of 65 and 45. So it would be 110 degrees. Lastly, if I want to find the measure of angle BCD, that's this angle here. If ABCD is a parallelogram, then I know consecutive angles are supplementary. If this angle is 110 and this angle is 110, then I know that angle BCD is supplementary to them. So that would make it 70 degrees, because 110 plus 70 equals 180. The last theorem we have is Theorem 6.7. If 3 or more parallel lines, so you remember our theorems about parallel lines cut by transversals, well, this is a set of 3 or more parallel lines, they're cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So AB, CD, and EF are all parallel lines. If I know that this transversal, AE, cuts these into congruent pieces, then I know that this other transversal, BF, also cuts this into congruent pieces. That's Theorem 6.7. Let's check for your understanding. What are ED and FD in the figure at the right? Well, if CD, BE, and AF are all parallel lines, and they are cut by this transversal CA, so that CB and BA are congruent, then that means this transversal, DF, is cut into congruent segments as well. So if EF is 12, then DE would be congruent. So ED would be how much? 12. So the whole segment, F to D, would be how much? 24 will be 2 times that, or 12 plus 12. Be prepared for tomorrow's notes quiz.